So we covered looking at approximating numbers using the binomial expansion and how we can evaluate things like that. What I'm going to do here, I've got a couple of questions that I'm going to give you. I want you to read the questions, pause the video, have a crack at them, come back and check your solutions to them. So here you go. I want you to calculate these powers of these numbers to three significant figures. So the first one's 1.04 to the 4, second one 0.7 to the power of 5. Have a crack at them. Go for it. So the first one is 1.04 to the power of 4. Now remember, question like this, we always want it written in the format of x plus y to the power of n so that we can use the binomial expansion. And for something like this, remember we always want 1 plus or minus something. Well, in this case it's bigger than 1, so it's going to be 1 plus something. 1 plus 0.04 is the equivalent of 1.04, and then my power stays the same, so it's to the power of 4. What I then do is I expand it using the binomial expansion and see how I get on. Remember, if you get to a point where your terms are not going to add anything to your final solution, which in this case is rounded to three significant figures, so I have to go to the next significant figure to be able to do that, I'm then not going to bother calculating. Now for this sort of one here, because I'm doing 1 plus, I know I'm going to have a number before the decimal, so essentially for three significant figures here, I know that that's essentially going to equate to 2 decimal places, so I've got to go to my third decimal place overall. So let's start expanding. I know the binomial coefficients are all going to stay the same, so here it's going to be 40 to start with, times 1 to the power of 4, plus 41 times 1 to the power of 3 times 0.04, plus 42 times 1 squared times 0.04 squared. If I then do my next term, 0.04 to the power of 3, my first non-zero term is going to come in the 5th decimal place. So that's going to push it beyond where I need to go. So actually at this point, what I can do is just do that. I know there's going to be more terms, but I don't need to worry about calculating them. There's no point in giving yourself the extra workload when it's not going to contribute to your overall final answer. So let's stick to doing these three parts here and then working it out from there. So my 40 times 1 to the 4, that's quite simply 1. I've then got 41, which is 4, times 0.04. That ends up giving me plus 0.16. I would then do plus 42 times 1 squared times 0.04 squared. What that would then end up giving me is plus 0.0096. Now if I then did the next term, I'd actually get 0.000256. Now again, the third decimal place for that would be 0. So it's not going to contribute to anything, so I don't need to worry about doing anything beyond that. All I need to think about is what I've got here. So if I add all of this together, I get 1.1696, and I know for three significant figures, I cut it off here because I start with a non-zero value, which then ends up giving me 1.17. So there you go, 1.04 to the power of 4 approximated to three significant figures is given by 1.17. Second question was 0.7 to the power of 5. Again, I want it written in the format x plus y to the power of n. Now I want to start with x being equal to 1. So if I want to go from 1 to 0.7, I've got to do 1, take away 0.3, then all to the power of 5. And remember, for my binomial expansion, it's got to be a plus, so it's going to be then 1 plus negative 0.3 all to the power of 5. Now that I've got that, I can use my binomial expansion on it and then take it from there. So my first term is just 50 times 1 to the power of 5, well that's just 1, plus 51 times my 1 times my negative 0.3. I've then got plus the 52 times, in this case, negative 0.3 squared, plus my 5, 3 times my negative 0.3 cubed plus my 5, 4 times negative 0.3 to the power of 4, and then my final term is just plus my 5, 5 times negative 0.3 to the power of 5. So I've got all of those. Now I do every single one of the terms all on its own, and what I then have to do, add it all up and round it off. So start by doing each term on its own. So my 5, 0 times 1, well that just simply gives me 1. I've then got 5, 1, which is 5 times negative 0.3, so I've got 1 take away 1.5. I've then got plus 5, 2, well that's just 10 times negative 0.3 squared, so that ends up giving me plus 0.9. I've then got my 5, 3, again that's just 10 times negative 0.3 cubed, that gives me take away 0.27. 5, 4, which is 5 times negative 0.3 to the power of 4, what that gives me is plus 0.405. And then my final term is 5, 5, which is just 1, is then times negative 0.3 all to the power of 5, which is then take away 0.00243. If I simplify this now, gather all this together, stick it in one go, what I get is that equals 0.53257. And if I round that then to 3 significant figures, I get 0.533. So there you go, that's that answer there. Just remember these steps. We always want it written as x plus y to the power of n, so 1 plus or minus something. That plus or minus something, we always want it to be between 1 and negative 1, because if that's the case, it slowly disappears as the power gets bigger. We want that to go, because that then gives us a nice approximation to the number, to however many decimal places or significant figures it wants the final rounding to. And remember what I said before as well. If you get to a point where your calculations are not contributing to what is going to be your overall answer, cut it off. Don't give yourself more work than you need to do. I did all of this one because every single part of it contributed. The previous one, I was able to stop because I got to a point where they weren't. Bear that in mind and look out for that. It will just make your life a heck of a lot easier when it comes to using the binomial expansion to get approximations of values.